Hi everyone. By now, you have completed your lectures on erythropoiesis and also heme as well as hemoglobin. So we are going to switch gear a bit when we move over to the clotting system in the body, or hemostasis. But before we start, I'd like to encourage everybody to start reflecting on this. If you were to meet somebody who got involved in an accident and is bleeding profusely, what would you do? What would be the first aid measures to stop profuse bleeding? So I'm sure some of you, many of you, will be thinking about applying pressure, applying bandages, or even tourniquet to the injured limb. And that's exactly what is being recommended by the American College of Surgeons. So what was being recommended were actually 3 steps to stop bleeding. The first step would be just to apply pressure with your hands if you do not have first aid kit available. The second step would actually be the application of pressure using dressing if your first aid kit is available. If hemostatic dressing is available, then it is preferred because that will kickstart the clotting process as well. Now, the third step would actually be the application of tourniquet if the injured site is on the wound, on the limb itself. Now, and why am I going through this? It's because the 3 steps that were recommended is actually meant to augment the hemostatic mechanism in the body. So ACS recommended 3 steps. In our body, hemostasis is actually 3 plus 1 steps. And what are they? So if you will imagine that you have a blood vessel that is injured here, right? There's a puncture wound. Now the immediate response to trauma or breach of the vascular barrier would actually be a reflex vascular spasm, right? So there will be a spasm of the blood vessel immediately after the puncture or the breach of the vascular wall. Now this vascular spasm essentially helps to slow down blood flow towards the puncture site and hence reducing blood loss. And you imagine that this is actually what we are trying to do when we encourage people to apply pressure or even use tourniquet to slow down the blood flow towards the injured site. Once vascular spasm happens, there will be 2 more steps in which the body tries to stop the bleeding. First would be your primary hemostasis, and that's your formation of platelet plaque, something that we will learn in today's recorded session. The other would be your secondary hemostasis, which essentially is your formation of blood clot, right? These 2 mechanisms will be the primary focus of our learning today in the first recorded session of hemostasis. Now, I would like to also highlight that the application of dressing here essentially is meant to also augment the secondary hemostasis process because the dressing itself has hemostatic agents that actually helps to promote or augment the initiation of the clotting pathway, and that's something that we will be learning later on as well. Now, once the clot is formed, it needs to be removed while the body starts to repair the wound. And that's when clot dissolution happens. It needs to dissolve and be removed as the body repair the injured site. Now, clot dissolution, it will be something that we will be learning in the next lecture. But for this particular recorded lecture, we will be putting our focus on primary and secondary hemostasis. So this brings me to the learning outcomes of this particular recorded lecture. The first, of course, will be to learn about how platelets is formed and the processes involved in primary hemostasis or the formation of platelet plaque. The second will of course be on your secondary hemostasis and how are the coagulation factors being involved in the process of triggering the clotting cascade. The third learning outcome will be on how bleeding disorders may happen if dysregulation in this coagulation pathway happens. The fourth would be to apply some of the diagnostic tests available to try and assess the coagulation system. For this particular recorded lecture, we will be focusing on the first two learning outcomes here, and we will keep the third and fourth learning outcomes to the face-to-face session following the recorded session later on. Right. Now for this particular recorded lecture, it will be also separated into two parts. The first part will be on primary hemostasis, and the second part will be on secondary hemostasis. So let's get started. Now before we get started on the clotting mechanism itself, I would like to revisit the concept of homeostasis, because as of all physiological process in the body, we always need to maintain an equilibrium, right? There always needs to be a balance, and that applies to the clotting pathway as well. And what we have here is that the clot formation must always be balanced well with the inhibition or the removal of the clot itself, because we cannot have clots randomly forming everywhere, but we cannot afford to have clots not being formed when there's a need to stop bleeding. So there needs to be a well-balanced and well-regulated mechanism, and this is what we are going to learn today. So when it comes to clot formations, there are a series of factors that actually encourage coagulation to take place. For example, the formation of platelets, thrombopoiesis, formation of platelet plaques, which would be your primary hemostasis, and of course, the activity of your clotting factors as well, and that's your secondary hemostasis. What counters the procoagulation pathway would be your anticoagulation factors, and that would be your anti-clotting factors, as well as the removal of your clots once it's formed, or fibrinolysis. Alright, and the anticoagulation factors will be something that we will be learning in the next part of your hemostasis lecture. For today, we will be focusing only on the procoagulation factors. Now you imagine that any dysregulation in this balance would be catastrophic. For example, if you have the balance tilted towards the anti-clotting mechanism as compared to the clotting mechanisms, that's when bleeding issues will happen. On the contrary, if there's more clotting as compared to the anti-clotting mechanisms, that's when the balance is tilted towards clot formation, and you may have aberrant clots forming everywhere in the body, and that's what we call thrombosis, the formation of aberrant clots. So when there's dysregulation in the coagulation cascade or the clotting system in the body, that's when we coin it as an umbrella term known as coagulopathies, any disorders associated with the coagulation mechanism in the body. For today's recorded session, we're going to focus only on the procoagulation factors. So the first will be our thrombopoiesis. The thrombopoiesis is pretty similar to what you have learned in your erythropoiesis lecture. It starts in the bone marrow and is initiated from the myeloid stem cells. Instead of your erythropoietin, what stimulates thrombopoiesis would be your thrombopoietin, TPO, right? And thrombopoietin is being produced constantly by your liver as well as your kidney. Upon stimulation, that's when your myeloid stem cells starts to proliferate and differentiate into your megakaryocyte, right? Your megakaryocyte is a huge cell that serves as a precursor for your platelets. But unlike your reticulocytes, it can't really migrate straight into the circulation. It's too huge to do so. So what happens is that it actually fragments or buds out into small fragments of cells, which will then be shedded into the circulation as your platelets. And these platelets would be that primary component that is involved in primary hemostasis. So as of all physiological processes, there needs to be some form of regulation involved. Likewise, for platelet formations, you cannot have platelets forming uncontrollably. So what regulates the amount of platelets in the circulation at a desirable level? And this is through a negative feedback loop by the platelets themselves, right? So the circulating platelets here actually helps to scavenge or bind the TPO in the circulation, and this helps to reduce or remove the TPO in the circulating system, and by doing so, reduce the stimulation of thrombopoiesis. So when there's high amount of platelets, there will be more TPO being scavenged, and thrombopoiesis will be reduced. And this would form a self-regulatory loop to ensure that the platelets is always maintained at a desirable level in the circulation. So platelets has a pretty short lifespan. It's about 10 days, unlike your erythrocytes that has lasts up to 120 days. All platelets will be removed in the spleen, just like your red blood cells. And your platelets is usually maintained at the optimal level of about 120 to 320 million per liter of blood. Now, when the platelet count goes below 120, that's a condition known as thrombocytopenia. And that's something that we'll discuss further when you see me in person later on. Okay, so we're done with thrombopoiesis. The next, we are going to move on to the formation of platelet plaques, which essentially is your primary hemostasis. Right, and to explain how platelet plaques is solved, I'm going to use this diagram here. And you can imagine that your platelets would be circulating freely in your blood vessels. When there's a breach of your vascular wall, there will be exposed collagen or connective tissues from the breach vascular wall. And when that happens, the first step towards the formation of platelet plaque would be your adhesion of the platelet to the exposed collagen wall. And upon the adhesion of the platelet, that's when the platelet will be activated, and it will start to change its morphology into something like a spike star-like cell. Right? So this activated platelet will then release series of granules containing platelet agonists, and the platelet agonists serve to attract more platelets towards the puncture site, and that's when it encourages further aggregation of the platelets. So yes, that brings me to the next step, platelet aggregation. So as more and more platelets is being attracted to the puncture site, it aggregates. And when it aggregates, they will be activated, and more platelet agonists will be released. With that, you can imagine that a self-reinforcing loop will be formed, right? A positive feedback loop with more platelet agonists bringing in more platelets aggregating and being activated, and you will see that the platelet plaque itself will start to grow. Now, some of you at this point might be asking, if there's a self-reinforcing loop and the platelet continues to aggregate, wouldn't this be catastrophic? Because we wouldn't want a huge platelet plaque to be formed and start clogging the entire blood vessel. So the question here is, how then does the body restrict uncontrolled plaque formation? How does the body ensure that platelet plaque is only formed at the puncture site and not every or anywhere else? And the answer to this question would be your intact endothelial cells. So yes, in sites that are not damaged, you have your intact endothelial cells. And these intact endothelial cells will continuously release nitric oxide and prostacyclins that helps to inhibit unintentional platelet activation and aggregation. With this, platelet plaque formation is only restricted to the part in which the vessel wall is damaged, and anywhere else with intact endothelial cells will be spared from the formation of plaque. So from this diagram itself, you have learned that platelet plaque formation essentially involves three processes: platelet adhesion, activation, and its subsequent aggregation. right? And we'll look into each of these steps in greater detail. Now, the first would be your platelet adhesion. Now, platelet adhesion is very much mediated by this circulating protein known as von Willebrand factor, VWF in short. VWF is essentially a plasma protein that is being produced by the platelets themselves, right? How it works is that VWF will bind the platelets to exposed collagen, and this is through the glycoprotein receptor available on the surface of activated platelets. When this happens, it activates the platelets, and that's when the morphology of the platelet starts to change. So if you look at the electron micrograph here, you can see that the inactive platelets here are just fragments of oval cells. The moment it gets activated, that's when the spikes starts to grow. There's appendages growing up from the platelets, and this allows greater surface area for attachment of the platelets. Right. Upon activation, platelets will also be triggered to release granules containing platelet agonists. And as what I've described, platelet agonist is critical towards the formation of the platelet flux, because that is the critical stimulator of platelet aggregation. How this works will be the next step that we will be discussing more in detail. Alright, so when it comes to platelet aggregation, we have shared that platelet agonist is being released by your activated platelets, and what's contained in the granules would be your ADP, thromboxane A2, and many other platelet agonists. But essentially, what you need to learn here are the two most important ones, ADP and thromboxane A2. Now, ADP serves to attract and activate more platelets, whereas your thromboxane A2 will continue to promote the aggregation of your platelets, as well as to stimulate greater vasoconstriction at the puncture wound. Now, other than your platelet agonists, when the platelet starts to aggregate, something needs to tie them together as well, and that will be fulfilled by your fibrinogen links. Right? So at the platelet plug, the fibrinogen will serve as a bridge that helps to tie your platelet together through the glycoprotein receptors on the surface of the platelets. But I have to highlight to everybody as well that the fibrinogen links are actually pretty weak. In other words, the platelet plugs is not a good solution to stop bleeding itself. It's just a temporary stopgap measure, right? The plug itself is rather weak because the fibrinogen links are not the strongest bond that you can find. So what this means is that once the platelet plug is formed, there needs to be further reinforcement to ensure that the bleeding can be stopped. And that will be fulfilled by your secondary hemostasis, or the formation of blood clot. How is this carried out is something that we will be discussing in the next part of the recorded lecture. Thank you.